Okay, this is our review 5.4. Leading up to this assessment in Unit 5, there are two reviews, 5.4 and 5.8. So I give you 1, 2, 3, 4, 5 functions here and ask you about some combinations. What does the expression f plus g of x mean? That means f of x plus g of x. All you have to do is add those two functions together. So f of x plus g of x is equal to 2x plus 3 plus x squared plus 1. If you can combine these things easy, and this one you can, okay? This is what? X squared plus 2x plus 4. What is the domain? I see no square roots, no fractions. The domain is negative infinity to infinity. The next one. What does the expression g divided by j mean? Well, this just means g of x divided by j of x. So g of x divided by j of x is going to be x squared plus 1 divided by j of x, which is x minus 3. Okay. What is the domain of this function? Well, remember, I'm looking for square roots and fractions to find domain restrictions. This has a fraction. I know that that denominator can never be 0. So if x minus 3 cannot be 0, that means x cannot be 3. So how do I write every number in the world except 3? That is negative infinity to 3 and 3 to infinity. So that is the domain of that function. What does h, you see the solid dot k mean? This is multiplication. This is h of x times k of x. So let's write the expression. So h of x times k of x is going to be the square root of 2x plus 1 times k of x, which is the absolute value of x minus 2. So these things are multiplied together. What's the domain? Well, domain restrictions come from two places, square roots or fractions. No fractions here, no denominators, but I do have a square root. So I know that what is under the square root sign has to be positive, cannot be negative. So greater than equal to 0. That means 2x is greater than equal to negative 1. X greater than equal to negative 1/2. So this domain is negative 1/2 to infinity. And it includes negative 1/2 because it's okay to take the square root of 0. Now the next one, I'm asking you to do some things, but you can omit where it says use the TI. So you don't have to omit the whole problem, but there are things you can do using the TI to find the domain. So let's skip the domain. So we are not finding domains on compositions, okay? So this is a composition, so G composition F. Remember G composition F, all that means is G of f of x. When I'm looking for the expression for this, I start with G of x. So G of x is equal to x squared minus 1. I rewrite it, which is open parentheses, because I'm about to substitute in f of x. So f of x is 3x plus 1. Okay, so that tells me my answer is 3x plus 1 squared minus 1. That is G composition F. Find K composition G. So K composition G, it might also be written like this, K composition G of x. All it means is K of G of x. So let's start with K. K of x is equal to the absolute value of x minus 2. So rewrite that with just open parentheses. then what needs to get substituted in there is g of x. And g of x is x squared plus 1. So this tells me that k of g of x is the absolute value of x squared plus 1 minus 2. So that's just the absolute value of x squared minus 1. And find f of g of 1. So the way we do these with specific numbers is, first of all, find g of 1 and then plug that into f. So g of 1 is 1 squared plus 1, which is 2. Take that number and plug it into f. F of 2 is going to be 2 times 2 plus 3. That's 4 plus 3, which is 7. So that's my final answer. Find h of g of 3. So the first thing you do is find g of 3. So g of 3 is going to be 3 squared plus 1, which is 10. You take that number and plug it into h. H of 10 is going to be the square root of 2 times 10 plus 1. That's just the square root of 21. Okay, and that should be the review for 5.4.